Fusion Mobile, quality e-learning experience on the go.
You're welcome back. Our topic today is captioned trigonometric tree. Trigonometry tree. Alright. Here I'll be talking about the graph of sine. I think I've omitted that. Graph of sine, cosine, and tangent graphs and tangents. Alright, I'll try my best to make them look as neat as possible, but I don't think I can get them perfectly with my notepad. Alright, tangents. Good. The graph of trigonometric ratios are plotted, just like your quadratic graphs. They're just plotted using the same simple rules involved in plotting quadratic graphs. You may refer to your methods of fitting quadratic curve as we studied previously, so that you can learn how to fit trigonometric graphs. That is, provided you've not learned that before, you can check on our tutorials on fitting quadratic curves, and so we use the same theories. Alright, we'll be fitting the curve for values ranging from 30 and upwards. Alright, so the first curve we'll be fitting is the sine graph. The sine graph, or the sine curve. Alright, and I believe every one of us have taken a look of these trigonometric ratios. Alright, the sine curve, assuming we are given the following x values or the following theta values. Let me use theta because I want to believe that many of us are too convenient with theta. Assuming we are given the following theta values. Alright, sine theta can be found. Assuming we have 30 degrees, we have 0, we have 30 again, we have 60, we have 90, then we have 120 degrees, and then we have 150 degrees, 180, 210, 240, and then we have 270, and then we have 300 degrees. Okay, we'll stop at this point because of space, and so we'll write their corresponding values. We'll try to write their corresponding values. Okay, I want to make my table look as neat as possible. Right, that's it. Okay, and then that's okay. Fine. I think it's now looking better. And so when you input values of sine for minus 30, you have 0.5, negative 0.5. Just punch with your calculator. That's why you have 0.8660, and for 90 you have 1. For 120 you have 0.8660, and then for 160, 150 you have 0.5. Okay, and then for 180 you have 0. For 210 you have minus 0.5, and then for 240 you have minus 0.8660, and then for 270 you have minus 1. For 300 you have minus 0.8660 again. Okay, so all you have to do is to plot the graph now, since we have for theta and the corresponding values of theta. Okay, good. You plot notes theta is fitted, okay, on the x-axis, while sine theta on the y-axis. Okay, I mean just the values. Okay, I mean the x-axis denotes sine theta, while the y-axis denotes values for sine theta, while the x values denote values for theta. All right, and so we'll be plotting the graph on the next page, and we'll name the graph the sine graph. Okay, remember that's what we'll have to do all the time. And then I have to choose my scale here, assuming I take my scales on this point. Okay, my scale becomes 1 cm to 30 units on the x-axis rather, and 2 cm to 1 unit, 2 cm to 0.5 units. All right, on the y-axis. All right, that's my scale. All these things are good, you note them so that they make your work look neat. Okay, let's try fitting this curve. I want to check out if I can easily get a straight line. Let me see if I can easily get a straight line from this page. Wow, this is better. Okay, let's try fitting a straight line here. Okay, I think here is fine. That's okay. All right, and then can I easily get another straight line here? Wow, this is okay. And so my line is good to go. I can fit my curve now, and this is my x-axis. Here I have theta, and this is my y-axis. Here I have sine of theta. Good. And so I'll be taking 1 cm. Alright, when you plot with your graph, I think it looks better than plotting on a freehand scale. Just manage my scales. It's not going to be very easy plotting on a freehand scale, but we'll manage this. And if this is 30 degrees, this is 60 degrees, this is 90 degrees, this is 120, and this is my 150 degrees, and this is my 180, and this is my 210, and this is my 240. Alright, so I need to extend the line more. Alright, I need to extend the line more. Okay, how do I do that without making mistakes? Okay, I think I can manage this. And then I have 270, and then I have 300, all in degrees. Fine. And so at this point I have minus 30 degrees, and this is my origin, and then I have minus 60, minus 90, all in degrees, okay, fine. And so on my y-axis I'll take, because the highest point I have there is the value of 1 and minus 1, so to 2 units I'll take this point as 0.5, and this other point as 1, and the same thing here. I'll take this point as 0.5, and so let me try extending this line so that I can have equal sides for 0.5 and 1. Alright, so I can fit here to be my minus 1, minus 0.5. Fine, I think we have something looking a bit good here. And so you can try to plot. If you look at your graph, we have at minus 30, sine theta is minus 0.5, Okay, that's the minus 30. Sine theta is minus 0.5. So they meet at this point where we have 0, and then at 0, sine theta is 0. They meet at the origin. At 30, sine theta is 0.5. Alright, they meet at this point. And then at 60, it is 0.8. It is 0.86. Okay, and we have approximately 0.9. So I can choose this point to be my 0.86. Okay, it's a freehand scale, but if you're using your graph, you have to be careful a bit. At 90, it is equal to 1 itself. If this here to be my 1. Okay, at 90, it is equal to 1. And then at 120, it is equal to 0.86. Alright, at 120 is equal to 0.86. At 150, it is equal to 0.5. Okay, that's the 0.5 at this point. This is at 150. And then at 180 is equal to 0. That's the 180 mark there. At 210, it is negative 0.86. And this is minus 1. And I want to pick my 0.8 to be at this point. Alright, so do not stretch, but I just want us to see what the curve looks like. Okay, and then at at 210 rather it is at 210 rather it is minus 0.5, so not really that place. Check it out on the table. When you're trying to study this topic, try to copy out the table on a plain sheet and then refer to our points. Okay, then at 240, that's where it becomes minus 0.86 when it gets to this point. And then at 270, it is minus 1. 270, it is minus 1. And then at 300, it is minus 0.86. It comes back to this point too. So we try to fit the curve perfectly, but that wouldn't really work out because of my notepad. Okay, join the points, join the points, join the points, join the points, join these points, join these points, and then join this point, join this point, join this point, and then fine. This is what we have as the sine curve. Alright, I want you to notice one property of the sine curve. Okay, it's originates at 0. The sine curve originates at 0 degrees and terminates at 180 degrees. Alright, so this gives us the sine curve we've been talking about, and then we're going into finding the cosine curve, the cosine graph. Okay, and so for the cosine graph, we have the values of x and the values of cos of x or cos of, yeah, let's try to alternate the use of signs here. Alright, I think this can help. so I have a line here too. Right, and then I have the next line. Wow, this is fine. And so I'm just trying to fit my lines so it can start up with computations immediately. Okay, alright, that's good, that's good, this is good too, that's good. Alright, I want to fit the lines, and then you can fix the values into the basics, the values for theta and other values too. Alright, I guess this will do. And for x values we have minus 30 degrees. Okay, x is in degrees, and then we have 0, we have 30, we have 60, we have 90, and then we have 120, 150, and then we have 180, we have 210, next is 240, next is 270. Alright, so we don't have anything for these spaces here. So the same thing if you punch on your calculator. Okay, for this I would like us to include minus 60 so that we can have a better view of what the graph is up to. And then for minus 60 we have 0.8, we have 0.8 sorry, minus 60 is 0.5. okay, and then for minus 30 we have 0.866, 0.8660. okay, and for 0 we have 1, and for 30 we have 0.8660, and for 60 0.5, 90 is 0, 120 is minus 0.5, and 150 is minus 0.8660, and then 180 is minus 1, 210 is minus 0.8660. okay, that's my point. And then 240 you have minus 0.5, and then for 270 you have 0. Remember, we'll have to plot minus 60 first, so you don't forget easily. Alright, just looking at the possibility of fitting this curve here. Okay, we use same scale as in sine. Our scale will be same as used for the sine, as used for the sine curve. Okay, and then the graph is the graph of the cosine. The graph of cosine. Okay, we'll fit the graph here so that we'll be looking at the table as we fit the graph. I think that will help better. Alright, so this is my y-axis, and then this forms my x-axis. From this point keeps running fine, this is good. And so this is my y-axis cos of x, and this is my x-axis for x itself. And so if I fit values using the same scales, I have minus 30, minus 60, and then I have 0 at the origin. I have 30 here, 60 here, 90 here, and then next is 120, this is 150, 180, 210, 240, 270, and that's all. And the highest value there is 1 and 0.5, and then I have my 1 here, and below I have minus 0.5, and I have minus 1 here too. Alright, so we can plot the values. You see, for minus 60, remember we said we'll start with this first, okay, because we omitted it from the beginning of the table. Okay, for minus 60 we have 0.5. Alright, so I guess this point we do for that. For minus 30 we have 0.86, which is close to 1. Alright, I pick a point here for my 0.86, and then for 0 I have 1. For 0 degrees we have 1, okay, at that point. And then for 30 degrees you have 0.86. Alright, somewhere here too. And then for 60 degrees you have 0.5, I guess somewhere here. Okay, and then for 90 we have 0. Okay, and then for 120 we have minus 0.5. okay, and then for 150 we have minus 0.8, and then I assume the value to be at this point. Okay, and then for 180 we have minus 1, and then for 210 we have minus 8.6. For 240 we have minus 0.5. okay, that's the point at that point there. And then for 270 we have 0. Alright, so we can fit the curve this way, this way, this way, connect to the next point, connect to the next point, and then you connect to the next point, and then you connect to the next point, you connect to the next point, you connect to the last point. Okay, you see the property of the sine curve. Okay, the property of the sine curve, sorry, the cosine curve property, it originates at 90 degrees. Okay, and terminates at 70 degrees, and then it originates again, and then it keeps having that number of points, a number of a maximum of 4 points in between before it terminates, and then it continues in that manner. So looking at the sine curve and the cosine curve, okay, they look like wave lines. All right, so I think we have an illustration of what we are talking about. We can now talk about the curve of the tangents. Tangent graph. The tangent graph is plotted in the same way the two graphs have been plotted. Okay, so we'll take values quickly so that we don't waste time here, since we've gotten the basic of what we want to learn. Okay, and here is tan x. Okay, we fit our table of values. Table of values. Okay. These are my table of values. Alright, and then I try to partition them so that you can fitting values into the tables for the corresponding angles. Alright, so for the tan of theta I have minus 90, minus 60, minus 30 all in degrees, and then 0, 30, 60, 90, 120, 150, 180, and then 210. Alright, and for tan 90, okay, you will have an error on your calculator, okay, which implies that the curve is discontinuous at this point, okay. But at 60, the value there is minus 1.73, minus 1.7321, okay, and at 30 the value there is minus 0.5774, okay, and at 0 it's 0, at 30 is 0.5774, at 60 it is 1.7321, and then at 90 it is discontinuous again, discontinuous, okay, and then at 120 it is minus 1.7321, at 150 it is minus 0.5774, and then at 180 it is 0, at 210 you have 0.5774, okay, and then at the other points we need to fit in here so that we can understand better what we're talking about. Okay, how many more points? I think 2 more points. Okay, we have 2 more points to fit in. Alright, space is too much, but we'll manage. Alright, you have 240, we have 270, okay, good. At 240 you have 1.7321, and then at 270 the graph becomes discontinuous again, discontinuous. Okay, so we find out what we mean by being discontinuous, why the error has been happening. Alright, we'll try to fit in this curve, and so we use same scale. We use same scale for the ones we've done previously, and for the sake of space we won't write the topic for the graph. We wouldn't bother writing the topic for the graph for the sake of space. Alright, okay, this is okay. Alright, so this is our origin. This is the point where you have tan x on the y-axis. The tan of x values will be fitted here, and then this is where you have your x-axis for fitting the degrees as x in degrees. And so these points are 30 degrees, this is 60, this one is 90, this is 120, and this is 150, this is 180, and then this is 180, and then we have 210, and then 240 and 270 at this point. Wow. And then on the left hand side you have minus 30, you have minus 60, and then minus 90. Good. This is my zero region, and then at this point I have 1, because the maximum value there is 1.7, so I have 1, and then at this point I have 2, and for this I have minus 1 and minus 2. So we start to fit the points. At 90 it's discontinuous, we can't do anything here, and so but at 60 we have minus 1.73 and other blah 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 blah. Okay, so I'll take this point as my 1.73. okay, and then at 30 you have minus 0.5. okay, the midpoint of here plus a little movement gives 0.57 and rest, and at 0 it is 0, and then at 30 it is 5.7. okay, I assume 5 to be here, and then a little movement to the top gives 5.7. alright, and then at 60 it is 1.7. okay, I think at this point I have my 7. okay, and then I can denote as the point there where they intersect. At 90 it becomes discontinuous again, and then nothing to be plotted here. okay, becomes discontinuous. alright, so but at 120 you have minus 1 point. The graph starts afresh. Did you notice that? okay, and then at 150 you have minus 1.5, 0.5. okay, and 0.5 should be at this point here. At 180 it is 0, and then at 210 it is positive 0.5, and at a point close to this mark. And then at 240 you have 1.7, you know, tracing from this point. alright, this should be my 1.7, and then at 270 again it becomes discontinuous. alright, so we can fit this curve using this. okay, this might not be the best, but I'm trying to fit something close to it. alright, so this is what your tangent curve looks like. You find out that at 90 it returns and becomes discontinuous, and then it means the graph originates at 60. property. okay, the graph originates at 60 degrees, and terminates at 62. okay, the difference there is that from negative 60 to positive 60, okay, it terminates. okay, and then you can as well look at it that the graph terminates after 5 points. okay, after 5 points the graph terminates. alright, I think we've come to the end of this class. Further properties can be explained from the graph, but for the purpose of this class we have to stop here. Do have a nice day. Goodbye.